All right, great. Well, so it's a great pleasure to be hosting Patrick Kaifosh today. So Patrick is he gained his undergraduate BSc in mathematics and physics from the University of Toronto. He then gained a PhD in neurobiology and behavior from Columbia University. He then went into the tech field and co-founded Control Labs, and he now works at Meta, but this is independent. The work he's talking about today is independent of his position there. So we're very glad to host you at Conscious Club, Patrick, and the floor is yours. Take it away.
Okay. Thank you very much, Stephen, for the invitation to present here, and also to Chris for the introduction to Stephen, leading to that. I'm very excited to be here, and it sounds like a great format for lots of discussion, and with people I assume know much more than I do about the broader topic of consciousness. So I'm really looking forward to what I could learn from this discussion. So the presentation today is about looking at the properties of consciousness and how they could relate to a role for mental experience in communication. And so just to go over the roadmap for today, we'll start with an objective, which is to understand the function of the behavior of consciousness. And the key to our approach will be, to compare consciousness with cognition, with the functions that the brain does, and see, how they're similar, how they're different. We'll in particular look at a hypothesis that consciousness is for communication. And the overall approach will be about considering systems of communicating agents. So think of like artificial agents in a artificial environment, kind of with getting rewards and what might be beneficial or not for them. And then the outcome of this is that we'll get to an account for the properties of mental experience, and see how that matches what we have experienced, what's been observed. So yeah, just getting into our goal, I think I'm sure many of you have thought about this a lot. You can think about either the feeling of consciousness, like what is it like for something actually to be felt, and the behavior of consciousness. And I think on the one hand, it's natural to care a lot about the feeling of consciousness. Does someone actually feel something? And are you that's what our ethics should be based on. You care or not about whether someone feels well or unwell, but there's some challenges there, in that whether or not something's felt or not, independent of the behavior around it, can't really be measured. And again, if it's independent of the behavior, it's not clear how it would influence anything in the physical world, or be subject to natural selection. So I think here we take a rather simple-minded approach, and just focus on the behavior of consciousness or mental experience, how it's reported, and maybe there's a downside hit there, and that could in theory differ from what's actually felt, but it has some major advantages in that it can be measured, so it's something we can think about within the realm of science, and then it's physically consequential, so we can think about it evolving or being learned, and having a function. And I'd also just argue that in general, the behavior of consciousness is quite an interesting thing, if you step back and think about it, because you're really going from what's a physical dynamical system, a complex, intricate system of many neurons interacting with each other, and then what's reported out as the behavior is a simpler account in terms of a system, of this being, this agent with intentions, with goals, motives, thoughts, reasons, etc. And from our justice system, it's very clear. We value this. We care about why someone did something, and then we're seeing that as well with the discussions around explainable AI, where not only do we really value understanding why an AI system might make one decision or another, but also that it's something that's quite hard to do. It's non-trivial. So anyway, with that, motivation for our focus, I wanted to think a little bit about how we might compare cognition and consciousness, and some things that are quite striking is there's some differences between them. So first of all, going back to the work of Lebet and others, what we often see is conscious experience can lag perception or decision making, and also, our nervous system performs a great many functions, and only a small subset of those are represented consciously, and those that are can often be represented with various distortions. The accounts can be confabulated. There can be self-deception there, and so what we see is that cognition and consciousness can be separate, and that gives us some hope that there might be some interesting comparisons that help us understand what the latter could be serving. So in terms of I think what the function of mental experience or consciousness is still very much under debate. I don't think there's any one preeminent idea that's emerged, but I think you could roughly group ideas into three main groups. So one idea is that it has something to do with general cognition. I mean, so maybe particularly challenging cognitive tasks that maybe require coordination across brain areas or attention, and that maybe consciousness has something to do with either that global availability or that attention. And so these are, for example, the global or neuronal workspace theories and some other ideas along those lines. There's another group of ideas around social intelligence, and I think roughly the idea is there is like, hey, if we build a really good model for our own behavior, where our nervous system has privileged access to a lot of what's going on, well, that may help us understand patterns of behavior, and then through those models we could better predict the behaviors of others around us, and then that could be useful to us. So this is very much about modeling yourself to be able to predict others. And then there's a third category that I think has been espoused by a number of people here, saying that the function for consciousness is more communication. So less necessarily about understanding others, but more about exposing information to others, so that they can coordinate behavior or to influence their behavior. So here I'm going to focus on that third category. I think it has some number of advantages. Again, for the first two, it's harder for me to understand why some of those distortions might be present, or and also issues around the timing. Well, the matter could make sense in terms of the second one, but maybe less so in terms of the first. And also the distinguishing characteristic of the behavior of consciousness is that we do have this ability to report it, to discuss it with others, and so you could say it's somewhat parsimonious just to focus on the communication side of things. So As I said, the approach I'm going to take is just to think in terms of a system of communicating agents, and see what ideas that spurs to mind. Um, so um, this is the simple model that we'll use to motivate our thinking. So and you can think of this as something, for example, that might be studied in the multi-agent reinforcement learning, machine learning literature. So typically, if you have just one agent, then it interacts with its environment. It performs various actions. Those influence the environment, and then it uh, makes various observations of the environment, which it can use to then condition its future actions on. And then as a function of the various actions it takes in the environment, it will receive various rewards. And so the agent will try to learn how to maximize its rewards and behave accordingly. And you can also have multiple agents, and so we're going to consider that case. And they can have different rewards that they can get. They can be collaborating, they can be competing, depending on the scenario, or they could be independent of each other. And then in this model, we'll consider a separate communication channel between the agents. So each agent can send a message that as an additional output from that agent, and then that can be an additional input to another agent. So that's these C arrows, as opposed to A for action and O for observation. Now you might say, okay, this addition seems unnecessary when modeling real biological agents, because all the communication we do is through the environment, right? We make some physical action, and then we another agent observes it. So you could say that the communication channels are superfluous. Where I think they are useful for our thinking is that they help us separate out communication through the environment that's really intrinsically about being through the environment, which with communication that is less intrinsically linked to the environment. So I like to think about different types of communication that can occur between animals. So one form of communication that's very much through the environment is observation, right? So, for example, you could have a predator observing its prey, and that and I think that is also, it's very like unilateral. The prey is not trying to be involved in that, but the predator very much is. Another type of communication that is very much through the environment is manipulation. So you can have so for example, here we see this fish with a lure, and it's trying to exploit the sensory system of another animal, such that it will be attracted to the lure, and then become the prey of this predator. And again, that's something that is very much intrinsically happening through the environment. It's exploiting sensory systems evolved to observe other things within the environment. And again, I think of this as largely a unilateral thing, where because it's the communication is really driven by the organism trying to do the manipulation, and the one that is duped would rather not be part of this. Then there are also signals that are intrinsically linked to the environment, because they're costly to produce in terms of real costs mediated through the environment. So a lot of these are involved in mating signals. For example, the peacock's tail shown here. Signals can also be costly in terms of the time they take to perform, so, the opportunity cost of not doing other things with that time, or maybe the increased risk of predation. And again, so these are all things that happen through the environment. This one, though, you could say is bilateral. Both the signal, or the sender, and the receiver are both involved in this in a way where they're kind of both opting into it. But I think the really interesting one is on the right. What's been termed conventional signals, and these are signals that have a very arbitrary relationship with the environment. Our language is an example of that, and they tend to be relatively cheap to produce. And I think that they're reasonably well modeled by these separate channels that act independently of the environment, and having those separate channels in our mental model we're using helps us just worry about the content of those signals, and not how it's going through the environment. And then we can ask, okay, so when would that happen, or not? And to think about this, it's helpful to really understand the asymmetry between the goals of a sender of a signal and the receiver of that signal. The sender and the receiver are separate organisms, so they each have their separate objectives. So that they're each subject to natural selection independently. And so for the sender, you can think the goal of communication is really about influence. It wants to influence the behavior of the receiver in a way that ultimately is beneficial to the sender. On the other hand, the receiver's potential to benefit from the communication is really about information. What can it learn from the sender signals that are useful to that, to the receiver, and will help it make better decisions that are ultimately beneficial to it. And so sometimes these goals are in alignment. Sometimes they're not. In the study of animal communication, economics, and game theory, there's been a lot of analysis about, okay, like when communication could happen, when it would be stable and persist, versus when it might not. And so we'll go through a couple different scenarios that could have an influence on that question, in particular in terms of the different payoff structures that one could encounter. So one thing is just, so we can ask, okay, how does the reward structure, the rewards obtained from the environment, compare for the sender and the receiver? And I think two cases are pretty easy to analyze. So if what I'll call the independent and the antagonistic payoff structure. So in the independent case, what I would say that would be if the rewards that the sender gets are independent of the actions of the receiver, then there's really no incentive to influence the receiver's actions at all, and so we wouldn't expect communication to occur. And then in even worse cases is the antagonistic payoff, where if whenever the receiver changes its actions in a way that benefits the receiver, if that causes harm to the sender, then the sender isn't going to want to provide any information to the receiver. And so you could say, okay, maybe the sender will try to trick the receiver, but again, if that's what's happening, the receiver will not pay attention to the sender, and in these antagonistic cases, there's no reason why it would ever believe any information, any again, the side channel communication from a sender. And so indeed, if you go and look in the environment and look at cases where there are organisms with independent or antagonistic payoff structures, you don't see communication of this conventional type between them. Like, yeah, you see observation, or you see manipulation in those previous examples. What you might see is some exceptions that actually, I would say, prove the rule. So, for example, you might there are some cases where a prey will indicate to a predator that it's detected it. So it could, for example, like towards the predator and, hey, I've detected you. But what you really see is that's a case where the interests are somewhat aligned. It allows a chase to be avoided that would ultimately require energy expenditure from both the predator and the prey. And so if the prey can indicate, hey, I'm going to escape because I know where you are, I know you're here, then that can be avoided. And so again, either what you see is really an observation or manipulation through the environment, or that there is actually some shared payoffs, for example, between host and parasite as well, where both have an interest in the survival of the host ultimately. So the more interesting cases are the shared payoffs and the mixed payoff structure. So in the shared payoff structure, any rewards received by the sender are shared by the receiver, and vice versa. And in this case, that there's a strong incentive for honest communication between them. Because they really share objectives. You could simplify things by saying the ideal that they would achieve would be a complete melding of their computational systems, where they would fully share any observations, inferences, predictions, action recommendations. They would teach each other. They could even share in computations between them. And also, because the payoffs are shared, the behavioral strategies overall tend to be relatively simple, in that that there's no competition, or no forming of different alliances, etc. The best example of this in biology would be the like eusocial insects, like bees and ants, for example, where they form a colony, and the reproductive success of many individuals in the colony is that of the queen. So it's one shared objective. And so, yeah, again, here you'd expect a lot of sharing of information, but I think it gets more interesting when you consider actually the mixed payoff structure. So here, sometimes when when the receiver changes its actions towards its benefit, sometimes that also benefits the sender, and sometimes that actually does not benefit this sender, or harms the sender. I think that that this is typical of most social animals, right? So they can sometimes cooperate to achieve a shared goal, but can also be in competition for each other, say over resources, mates, etc. Um, and this is the case that has also received the most study, and what you see here is that you can have communication, but it's it's mostly honest, but there can be instances of deception. And for the communication to be stable, generally it has to be mostly honest, otherwise the senders would ignore it. And so in this sense, what mostly honest means is like on average, sorry, the receivers would ignore it. What it means is on average, the receiver benefits from paying attention to the communication. And then the other requirement is like that there'd be some cost to a sender that deviates from the equilibrium strategy or the conventions of communication. And so that could take many forms, from losing credibility to retaliation, etc. So the sorry, excuse me. The interesting thing is, so here you can also have much more complicated behavioral strategies when there's many individuals. They can be cooperating at some times, not at others. They can form alliances and enmities. At equilibrium, there can actually be multiple different behavioral strategies that are present, and so in addition to potentially wanting to share all the forms of information that could be shared in the shared payoff scenario, I think there could also be more of an incentive to share about one's internal workings, so that could include like describing one's strategy, or even negotiating the strategy, coordinating with others, describing one's alliances and enmities, and also explaining the reasons for the actions, because especially where the strategies could be more complex, or where there could be many coexisting behavioral strategies. And where you could have animals or other agents rewarding those that are cooperating with them, and punishing those who are not, then it could be very important to account for one's actions to the others. And the general hypothesis is this, like accounting for one's actions, explaining one's strategies, and coordinating and negotiating them. That's where what we think of as mental experience, or experience of the mind, really comes in, so that we're able to perform that function. And that in the shared payoff scenario, we could probably get by more just by sharing their observations, the information that we have, without the need to share an account of of our strategies, etc. And that latter account of our strategies is really what we think of in terms of our mental experience. So think a little bit about how communication could then be implemented between these agents, and I think there's a couple of different ideas. One, the simplest being just like direct readouts. Again, if we're thinking in terms of neural networks, you could imagine, okay, you just have one of these agents, and you take a random projection the activations of the different units within that agent, and then you provide that to as an input to the other agent. And yeah, okay, so this would presumably have some information about what's happening inside that agent. It might be a bit difficult to process, probably take a lot of learning, but it might have some utility. But maybe with enough exposures and enough training that could become a useful communication. The agent could learn to interpret that and get some value out of that. The next thing you could think about would be like simple signals. So maybe, okay, once another agent has learned to respond to that in a somewhat predictable, you could the sender could then start to modulate those outputs in relatively basic ways. And I think about that, roughly analogous to a lot of communication. You see say like vocalizations between non-human animals, where it tends to read out something that is already represented in that agent's nervous system. Like, hey, I see a predator, I found some food, etc. But these can also be somewhat modulated by these social situation and what other animals are around, and so maybe think of them more as these simple signals rather than direct readouts. But the alternative is to really dedicate a lot of resources to this a lot of neural resources to this communication, and say like what we want to communicate more than just what is directly represented in this nervous system, but again, like some account of how that is happening. And so for this, it would be required to develop some of what someone would call a mind model, where it's a model largely separate from the basic functioning of the agent in terms of how it would take its observations and compute actions for them, but almost sitting beside that, taking inputs from that, but then the ultimate output of that being the substrate that could be then used to derive communication signals from. So if we think about that, we could say, okay, how much would what we would expect to arise from that, compare with what we see with mental in terms of mental experience. So yeah, one obvious consequence of that is again, like mental experience should be different from cognition. We're thinking of cognition again, largely about how the agent goes from its observations to its actions, and then again, the mental experience being that separate model for producing the communication to other agents. And I think this is reasonably well borne out, by evidence in the literature. Again, as mentioned before, most of what happens in our nervous system is not represented consciously. Even complex problem solving can have non-conscious components. For example, during these incubation periods, we often think of attention and consciousness as closely related, but conscious attention can even sometimes impair cognition. In this model, we might think of it as overhead. again, like a separate process, which might compete with some for some neural resources. So consciousness, legs, cognition, and perception. Again, that would be expected here. If it's a model receiving inputs from what's going on, it could take a bit of time to process those inputs uh, and model what's going on. Sorry. And then again, there's also some evidence of sensory processing and consciousness being dissociable, and a long history of reports showing that we can actually be strikingly unable to report on the influences of our decisions, and also that many of the accounts that we provide can be confabulated. This most strikingly in cases of split brain patients, where it's not possible for the information guiding the decision to get to the language centers that then provide the explanation for what has happened, but an explanation is still provided nonetheless. It's just clearly different from what caused the action. But the idea here is more broadly that you could say almost like all of these explanations are confabulations with varying degrees of information that they're conditioned on, but it's just more obvious in some cases than others. Another thing we might expect is that if again this is a model that's for communicating to others rather than for computation within the agent itself, that it could have a number of biases within it that are self-serving for the purposes of influencing the others, and so that those could be biases either to distort what the message being given in terms of like, hey, what how one might want to influence the other, and it could also be biases less about what the message is, but how credible that message is. So for example, overconfidence is something that's noted often for the agent that is going and taking observations and then figuring out the right actions to perform, forgetting the other agents. Overconfidence is not very useful. It would be detrimental. But again, if the goal is specifically to influence other agents, then there could be a great advantage to overconfidence. Again, so similarly, there could be exaggeration of the agent's ability, its influence or its power, the degree to which it is pro-social, especially again given in these mixed reward scenarios that there can be punishment of agents that harm others and rewards to agents that benefit others. So there's lots of documentation of such biases in literature on self-deception, cognitive dissonance, and cognitive biases. So those are two things. Then we could dive a little deeper into, okay, so beyond the consciousness or mental experience and cognition being separate, we could ask, okay, which neural functions would we expect to be represented in mental experience, and which would not be, because we're the hypothesis is that mental experience is really again separate model running on the side, just for constraints on neural resources, energy, et cetera. We would expect that only things would only be represented in that mental experience if there was some utility to that. And so here, of course, the utility would be these would be things worth communicating about. And if something was not worth communicating about, then that would be excluded. And so, indeed, what you see is okay. Lots of representation of higher order executive functions like plans, goals, um, and higher level sensory percepts, but not a lot of the lower level processing along the way. And similarly in terms of motor output, representations of like, hey, what limb is moving, things that could be observed by others easily, as opposed to the mechanics of how that happens. Like, hey, no represent. Like, okay, what's going on to stay balanced, or which muscles are being activated to move that limb or make that movement. That tends not to be represented, as opposed to again, like which joint angles moved. Well, that can be observed externally, and that is represented. That's information being of interest. So if something would never be of interest to other agents, then that should be excluded. That said, being of interest to other agents might not suffice for something to be consciously experienced. In particular, that there might be some very sensitive information that the agent doesn't want to risk leaking to other agents, and so that could be excluded from the representation. So here I think of the one potential instance of this is around say sexual attraction, the causes of that, why someone might be attracted to one individual versus another. Those can be quite opaque. Think of like Romeo and Juliet, the star-crossed lovers. That there's no explanation for why that particular person or so, and it's seems inconvenient in some ways, but maybe there's some rationale. It seems despite the common statement of love is blind, it seems that something that would presumably be so important evolutionarily, like that there must be some processes going on that are carefully selected there, and yet they don't seem to show up so prominently in people's reported mental experience. Then we can also ask, beyond what's conscious and what's not conscious, what actions are represented as voluntary or not. So at the end of the day, in these physical systems, whether agents or ourselves, the idea of a voluntary behavior is is amusing, let's say. But despite all of these behaviors happening from physical systems evolving, some of these are accounted for as voluntary, and some are felt to be involuntary, and why is that? And so one pattern that this might suggest as well. Okay, so a voluntary behavior might be one that is worth rationalizing to others, where it's useful to provide an explanation of, okay, this agent, I did this because of that, and not because of that. And so we would expect to be included would be probably a lot of these higher order executive functions that other agents would be particularly interested in, and things to be excluded. Well, first of all, anything that's not conscious, because to begin with, that wasn't of interest to others, or and but also anything that's, say, like too predictable to warrant an explanation, or maybe something that is too important to be subject to social pressure, like breathing is involuntary. At least at some point you can hold your breath for a little bit, but at the end that will become involuntary, which is maybe just to, you don't want to be held accountable for explaining why you did or didn't breathe, or it doesn't seem that it would provide any benefit. And so anyway, one can go through and try to look at all the different neural functions, things your nervous system does, and categorize them based on whether they're unconscious or partially conscious or conscious, and then whether if they're motor behaviors, whether they're voluntary or involuntary, and some behaviors seem to roughly fall between the categories, but this was my attempt to do so, and I think things seem to fit pretty well the principles that we described above, and maybe I'll have some other thoughts on that. We can the discussion describe if there are other behaviors that you think might be important thinking about. But what do we see? Again, one thing, maybe this is sort of okay, it's obvious the right word, or it's something that one wouldn't question, but when is it there don't seem to be any voluntary behaviors that are unconscious, or which can both make sense in that generally if they're unconscious, they're not of interest to others, and so if it's not worth communicating about, why is it worth communicating an explanation for? And then also, if also it'd be hard to provide an explanation for a behavior that you're not aware of. So now it's a little funny saying okay, if the mental experience is for communication, well, why is it that you have some communication that's still involuntary? And so that and I think that can make, I don't, upon further reflection, I don't see any reason why there couldn't be multiple channels of communication. Evolution never requires that there'd be just one way of doing something. And then when you think more about it, you think, okay, each of these forms of communication could have their separate uses. And so when we think of an involuntary communication, we think more about those direct readouts and simple signals discussed on an earlier slide. And maybe actually, these have a very useful purpose of, although the repertoire is quite limited, there's a sense of them being more credible as, again, direct readouts of what's within the nervous system. Whereas, when you go to voluntary communication, well, that creates an explosion of flexibility. And you can communicate, all that has been developed within the mind model, but it's this rich, flexible linguistic communication, but there's a downside as well, which there could be some sophistry in here as well. People, there could be more deception, and so maybe having these two channels is actually useful. Another thing we would expect is okay if mental experience is arising from this separate model for communication. That's some neural circuit that could play out in different differently in different individuals, and also plasticity could happen. So things could change over time as a function of development and so forth. And so that the contents of mental experience might not be actually fixed, but could be variable, and so across individuals you do see some variation in these things. So I think one thing that's reported is so when you're like hairs stand on end, like goosebumps, it's called piloerection, and you have some. For most people, that's a involuntary response, but there's reports of some people where that is a voluntary behavior. With skill development, we see differences in how things are represented. So usually when you're learning a new skill, it's a highly conscious behavior. You're paying attention to every little detail of what you're doing. But then by the time you become an expert, you can perform it subconsciously. You're barely thinking about what you're doing, and again, from this perspective, that makes sense. In that, when you're a novice, you're maybe most likely to want to communicate about that behavior to get advice to improve, but also you're more likely to make mistakes that you might want to account for to others, and so. One can also think about, childhood development. If a big part of this is about, accounting for your behaviors, I think that the pressures on young children to account for their behaviors are lesser and different than those on adults, and so maybe more of what's going on there is about learning that this skill of producing this model of mental experience, and learning what will come across as credible or not to other individuals, and then also the one's behavioral patterns also change a lot over time, and so having a good model for how someone behaved as a very young child might not be so useful for predicting their actions as an adult. So there might also just be less interest in those explanations being retained, and so maybe there we could understand somewhat of the selection pressures around infantile amnesia. We don't tend to have a lot of explicit memories from when we were a very young child, and if you think about that, for accounting for our behavior in ways that predict our current behavior, those are kind of useless. So and we can think more broadly about the time scales of memory. We tend to have a much better representation of recent events. Those are probably the ones we'll be most likely to be asked to account for once time has passed. The likelihood of us being asked to account for it is much lower. But we also, have stronger memories for social salient events, and those tend to persist longer, and maybe those we think we're more likely to have to account for that at a later date. Of course, there's various ideas of the mechanisms for timescales of memory and infantile amnesia, but I wouldn't consider that precluding an explanation like this. I think, if selection pressures were different, one might expect different mechanisms to evolve with different timescales. So, for example, although we, I might not have an explicit memory of learning how to ride a bike, and you can there's the old saying of, you can go many years without riding a bike, and you hop back on it, and you remember how to do that again. So and that makes sense. The implicit memory could still be quite useful, even though the explicit memory isn't. And then I also saw from again some people here, there's ideas about how cultural learning could also influence the what is represented in one's mental experience. And again, it makes sense if this is for communicating to others, the expectations of the culture you find yourself in, it would make sense that it should be tuned accordingly. Okay, and so the that goes through the main idea. We could then think about, okay, what might this mean for, like, okay, where might you expect to see mental experience like this be present, and where not. I think the ideas are similar to what might expect from other social hypotheses for the communication hypotheses for mental experience. We would expect that this would occur in animals that were sufficiently social and had the communication capacity to make use of this. And I think here maybe that thrown in this additional sense of that it would be important that there'd be shared, so that there would be mixed payoffs as opposed to purely shared payoffs. So that there'd be really that pressure to account for what was operating inside one's nervous system. And then one can also speculate on the artificial side of things. And I think here is a point is that the hypothesis is that mental experience is not arising from the ability to say compute appropriate outputs from inputs, but again the need to account for how that's done. Obviously, the mechanisms in artificial systems are potentially quite a bit different. So anything there gets into the realm of speculation. But I think we'd say, like, most systems that we've seen developed don't have these properties. They're not developed in these like multi-agent scenarios, and they're generally not accounting for their behaviors in the same way. So just going back to the roadmap for today. So we started off with this objective of trying to understand the function of the behavior of consciousness, and we've done that by we've focused on a hypothesis of consciousness being for communication, and then we've evaluated that in terms of like how consciousness compares with the underlying cognition, and sort of the Zoom is just covering up some of my slides, so I can't see that. And then we got to this what I think is a nice account for a number of properties of mental experience. And so just we can then compare with these various other hypotheses for what function mental experience could have. And I think on a comparison, I'd argue that this hypothesis advanced here around social influence does quite well. It fits well with verbal, the availability for verbal report being really the distinguishing observable feature of mental experience. It accounts for why there could be such distortions in our in the mental experiences that we recount. It accounts for why not just that mental experience would be a sparse subset of the many things going on with our nervous system, but accounts, provides a specific account for which things should be in and which should be out, and similarly for voluntary behaviors, which should be voluntary and which should be not. And I think it's very reasonable then to expect that because we're thinking about benefits really to the individual with this system as opposed to just the group, as you might require in hypotheses that center around more the shared benefits of coordination from communication. I think the case for this being something that could be selected for is all the stronger. So that's the idea. So just to recap on this question, again, I think a lot of us are interested in the feeling of consciousness, but all we can really study is the behavior of consciousness, and we kind of hope that the two are related. I think one thing that's nice here is that we what we see is there's a lot of differences between the mental experience and the underlying cognition or neural function that is intended to represent, and so one way I think about it is like, hey, we experience ourselves not as we are, but as we ought to seem to others. If our feeling of consciousness also seems to agree with that, although that's something maybe we can never study, it might give us some hope that it would seem extremely coincidental that both would have some of these same properties. Another way of thinking of this, like, okay, if you want to say, understand like what the consciousness of a bat might be like, let's say, maybe the question is not really like what it is to be, what it is like to be a bat, but more, how would a bat want to appear to other bats? And so, maybe we have to ask similar questions about what it's like to be a human, and it really being about, okay, like how we want to appear to other humans. And might lead to conclusions that are very different from what you get if you just like look and ask like what is it like to be a human, or what does the human's nervous system do. So that's basically this. I'll just leave up these key ideas that we've gone through, and then we can go into our discussion, which is the part that I've been most looking forward to.
Great. Thank you so much, Patrick. That's great. Give you a round of applause for a lovely talk.
Thank you.
Yeah, very deep and interesting ideas here, and I'm sure there will be questions from the audience. So let's just make sure we stop our recording for